Welcome everyone. We have already discussed about the representation of vectors and their unit vectors. Also we have discussed in our first video the one-dimensional, two-dimensional and three-dimensional representation of vectors. Now in this video we are discuss about the vector addition and subtraction. The vector addition is different from scalar. In case of scalar we are adding 2 plus 3 equal to 5, but 2 vector plus 3 vector not equal to 5 vector. This is depend on direction, so we cannot add vector directly. So there are different law. How can we add two vectors? Suppose a vector directed along this direction and another vector b vector directed along this direction. So we want to add a plus b. In this case, the head of A and the tail of B will be contact with other. So in this case, we draw the figure as A vector plus B vector. Then it represents a triangular arm of triangle. Then the third arm, two arm A vector and B vector represented by A vector B vector. The third arm represents the resultant vector R. So in this case, this is also called triangular law. Where in case of triangular law, generally suppose A vector and another vector B vector represented by two sides of a triangle, then the third arm represents the resultant vector. In this case, remember that two vector A plus B, that means consider the center of the triangle. The direction of vector in anticlockwise and direction of B vector in anticlockwise. So A vector and B vector, that both are in anticlockwise adding, but the resultant vector in clockwise direction will be in clockwise direction. So in this case, generally we can also consider 2 point O, P and Q, 2 point. From you are to go from O to Q. So first of all you go from O to P by a vector, and then we will go to P to Q, then the resultant path from O to Q directly. So further we consider A vector O to P, then B vector P to Q, then C vector Q to suppose R or S, then D vector S to T. So the final path, the resultant vector will be along from the initial point to the final point. This is the resultant vector. Now how can we add A, B, C, D by triangular law? First of all, we draw this this is O, P, Q is a triangle. Then A vector plus B vector, the sum of two vectors represented by the third arm of the triangle. And this is also a part of a triangle OQS. This is also a triangle, and one of the arm AB along this direction and another arm C, both are anticlockwise. Then the resultant will be O to S but clockwise. So we can write in this case A plus B plus C. In the similar way, we can add D 0 to O to S, A plus B plus C along this direction, then S to T along this direction. If you consider the center of the triangle, then both are anticlockwise, O to S, S to T. Then the resultant R will be clockwise. So you can write R vector equal to A vector plus B vector plus C vector plus D vector. In this way, we can add a number of vectors. So this is how we get the polygon law from triangular law. Now there is also another law is called parallelogram law. In case of parallelogram law, suppose two vector P vector and Q vector two vector represented by 0 to, suppose in this path a point and b point. So two vector OA and OB represented by p vector and q vector respectively. We want to add this by parallelogram law. Complete the parallelogram. Parallel to OA, draw a arm parallel to OA and draw another parallel arm same as OB. Then we can also write this arm as q vector because this magnitude same and direction same parallel. Then these two vector both are equal. And similar way, 0 to O to A and B to, suppose this point C. These two arms length also equal and their direction are parallel. Therefore, this two vector P vector and this is also P vector. These two are same. Consider the angle between P and Q theta. So, in this case, according to parallelogram law, the diagonal represents the resultant vector. This is the diagonal. That means, suppose two vector act along this direction, then how can we add this two vector? Complete this two vector parallelogram by this two vector. By parallel this arm, complete a parallelogram, then the diagonal represents the resultant vector. So how can we get the magnitude of resultant vector? And for this purpose, we need to draw a perpendicular on this OA line. Suppose this point is D. So this is a right angle triangle. Triangle OCD is right angle. A right angle triangle where this is the 90 degree. This point 90 degree right angle triangle. So if we are to calculate the value of R, this is the diagonal of this triangle ODC, right angle triangle diagonal. So how can we calculate the diagonal of the triangle OC? We know that a right angle triangle diagonal square. We know in case of right angle triangles, suppose a right angle triangle ABC, we can write AC square equal to AB square plus BC square. So by this formula, we can write OC square equal to OD square plus CD square. OC square equal to R square. This is the magnitude of R. OC, the length is always magnitude and direction means the direction. So OC square means R square. But OD, OA plus AD, OA plus AD whole square plus CD square. So we have to calculate OA equal to P and AD. So this part ACD, this is also a right angle triangle, and AC equal to Q and CD, this is right angle triangle. Suppose this is like this 90 degree D point and A point C point. Now AC which is equal to OB equal to Q and 90 degree, and this angle theta also angle theta, because these two are parallel are similar in angle on a same line. These two parallel line on the same line, two parallel line always make angle theta. So we can write this value as theta. So we can write CD equal to Q sin theta from trigonometry formula and AD equal to Q cos theta. I think this you are also know about this from trigonometry, and from this formula we can write AD equal to Q cos theta whole square plus CD equal to Q sin theta whole square R square, and a plus B whole square formula you get P square plus Q square cos square theta plus 2PQ cos theta plus Q square sin square theta. Now this, so we can write this as R square equal to P square plus Q square cos square theta plus 2pq cos theta plus q square sin square theta, or p square plus q square cos square theta plus sin square theta equal to 1 sin square theta plus 2pq cos theta. So you can write p square plus q square plus 2pq cos theta r square, or r equal to root p square plus q square plus 2pq cos theta. This is the magnitude of resultant vector r. Now to find the direction, we redraw the figure as this is p vector, this is q vector, and the parallelogram. Then diagonal vector represent the resultant vector r. Now to find the direction of r, let us consider r makes an angle alpha, and this is theta. So to find the angle alpha, where resultant vector makes an angle alpha with respect to p, so we can write, this is already draw 0 O A B. So to find the alpha, we can write as tan alpha equal to perpendicular divided by base from this triangle ODB. Triangle ODB, from this ODB right angle triangle, the tan alpha equal to perpendicular BD divided by base OD. So BD, we have already calculated Q sin theta. Q sin theta divided by OD, OA plus AD. OA plus AD equal to, we can write OAP. This is the O length of P vector, means P length, and AD, we have already calculated ABQ cos theta. Q cos theta. So tan alpha equal to this below, and alpha equal to tan inverse Q sin theta divided by P plus Q cos theta. This is the formula, the direction of resultant vector with respect to P. This is the angle alpha is the angle of R vector with respect to P vector. So you can find the magnitude R by this formula. This is very important formula, number 1. And to find the direction of R with respect to P, we can get by from this from equation number 2. We also get the angle makes with the Q. So if we get theta and alpha, then we can find the resultant vector makes angle Q, theta minus alpha. Okay, so by this way we can add two vectors P plus Q. Now we want to discuss about the resolution of a vector. We have already calculated from PQ, from P vector and Q vector, the resultant vector is R vector. So from P to Q we get R as R equal to root P square plus Q square plus 2PQ cos theta. So if you want to find the resultant vector from PQ, we need to use the equation R equal to P square plus Q square plus 2PQ cos theta. So how can we get PQ from R? This is called resolution. That means resultant vector along this direction, component of R along this direction, and component of R along this direction. This is called resolution. From P to Q we get resultant, and from the resultant we want to resolution to P to Q. So how can we get this? As we already know that this Q, this is Q below, and this is also Q. So from the triangle OAP, three arms of a triangle where OA equal to P, AB equal to Q, and OB equal to R. three sides of a triangle, and if this theta angle between P and Q, so we can also write this is angle theta. So this will be 180 minus theta, and if this is alpha, the angle between R and P is alpha, then we can get the angle between angle OBA. Suppose this is delta. So how can we get delta? We know the sum of three angles of a triangle is 180 degree. So we can write alpha plus delta plus 180 minus theta equal to 180 degree. Then 180 cancel. Delta equal to theta minus alpha. So we can write delta equal to theta minus alpha. So we redraw this part OAB as this is alpha, this is theta minus alpha, and this is 180 minus theta. This is P, this is Q and R. So how can we get PQ from R? From this triangular law. Also we know from trigonometry a general formula. Suppose this is A, B and C, three arms of a triangle or side. Then suppose the opposite angle of A is alpha, and opposite angle of B equal to beta, and opposite angle of C is gamma. Then we can write sin alpha divided by opposite arm A, sin beta divided by opposite arm B, and sin gamma opposite arm C. This is a very important formula in trigonometry. By using this formula, we get from sin 180 degree minus theta divided by R, sin alpha divided by Q, and sin theta minus alpha divided by P. And from this part, we can write this is equal to this, or sin theta minus alpha divided by P, sin 180 minus alpha theta. 180 minus theta means from the triangle trigonometry formula we all know. So 180 minus theta is sin theta and divided by R. So from this expression we get P equal to R sin theta minus alpha divided by sin theta. This is the general equation. Another formula comes from the sin 180 minus theta divided by R equal to sin alpha divided by R. Then from sin 180 minus theta divided by R equal to sin alpha divided by Q. So from this relation we get Q equal to sin alpha divided by R sin alpha divided by sin 180 minus theta equal to R sin alpha divided by sin theta. So we can write R sin alpha divided by sin theta. This is another general equation. So suppose this theta is 90 degree. We want to resolution of a vector perpendicularly. So in the coordinate system, if along x and y these two are 90 degree, we know in coordinate system perpendicular, let us consider a vector r along this direction. Then component of r along x equal to p, suppose p say, and component of r along y equal to q. Then the similar formula from parallelogram law, theta will become 90 degree here. So we can write theta equal to 90 degree by substituting this below and write this as alpha. So substituting this below in equation number, suppose this equation number 1, you can write any number of equation. This is generally these are very important formula, need to remember. So from equation number 2, we get substituting theta equal to 90 degree, we get theta equal to 90 degree means p equal to r sin theta 90 degree minus alpha divided by sin 90 degree equal to r cos alpha. So we can write p equal to r cos alpha, and q from equation we get q equal to r sin alpha divided by sin 90 degree. That's sin 90 degree equal to 1. So we can write q equal to r sin alpha. These are very important to remember. P equal to r cos alpha and q equal to r sin alpha. So we get resolution of vector into perpendicular direction along x, y. Suppose r vector makes an angle alpha, then component of r along x-axis is equal to p equal to r cos alpha, and component of r along y-axis is equal to r sin alpha. This is generally whatever a vector makes an angle theta. Suppose r vector makes angle theta, then component along this direction x-axis we can write r cos theta, and component along y-axis perpendicular direction r sin theta. That means the r vector makes an angle x-axis theta, so r cos theta. If r vector makes an angle another angle along y-axis, suppose we consider further along xyz coordinate system, xy and then 3-dimensional coordinate system z, and this is the r vector. If r makes an angle alpha with x-axis and r makes an angle beta with y-axis and r makes an angle gamma with z-axis, then we can write component of r along x-axis is also can be written as rx, and component of r along y-axis written as ry, and component of r along z-axis can be written as rz. We can write rx r cos alpha, ry, it will be cos theta, always cos. Whatever r makes an angle theta with an axis, always cos. Therefore we can write r vector makes an angle alpha with x-axis. The component of along x-axis will be r cos alpha. Then r vector makes an angle beta with y-axis, then we can write r cos beta. And similar way, r vector makes an angle with z-axis gamma, then we can write rz equal to r cos gamma. So we can also represent it by r equal to rx I cap plus ry j cap plus rz k cap equal to r cos alpha I cap r cos beta j cap plus r cos gamma k cap. So these are called all direction cosine. R cos alpha, r cos alpha, cos beta, and cos gamma is also called direction cosine. So here we can also write r vector as r dot r cap, where r is unit vectors, and we can command the r from all these. R equal to cos alpha I cap plus cos beta j cap plus cos gamma k cap. So we can find from this relation, this is the unit vector of r, and we can write unit vector cos alpha I cap plus cos beta j cap plus cos gamma k cap. And we also know the modulus or magnitude of unit vector always 1. That means mod of r equal to 1. The mod of r means from this relation we get root cos square alpha plus cos square beta plus cos square gamma, or we can write from this formula, and from this formula we can write cos square alpha plus cos square beta plus cos square gamma equal to 1. This is the important formula of direction cosine law. Now, in case of vector subtraction, it's very simple. Just adding two vectors. Suppose we want to subtract b vector from a vector, and we can write it as a vector minus b vector. This can be written as a vector plus minus b vector. That means we want to the b vector in the opposite direction, so that we can redraw as in case of parallelogram law. If this is a vector and this is b vector, then a vector plus b vector represented by this diagonal, a vector plus b vector, and along the direction b, then opposite direction will be minus b vector. So we can redraw again a parallelogram, complete a parallelogram. Then this diagonal represent a vector minus b vector. So subtraction is nothing, just adding. But whatever you subtract is need to redraw in opposite direction. So if you subtract b, then need to be redraw in opposite direction. Then same parallelogram law. By this parallelogram law, you get a vector minus b vector. This is the subtraction, vector subtraction. If you want to subtract a vector from b vector, then a will be redrawn in the negative direction, minus a vector. Then complete a parallelogram. The parallel of this arm will be parallel of this arm. These two arms will be parallel and these two arms will be parallel. This is parallelogram. And then the diagonal, this diagonal represent b vector minus a vector. B vector minus a vector. By this way, we can subtract any vector from another vector. And we consider some examples. Suppose a vector P equal to 10 Newton force and another vector Q 20 Newton force, just acting at an angle theta equal to 30 degree. There P equal to 10 Newton, Q equal to 20 Newton, acting with theta equal to 30 degree. To find their resultant vector, we directly apply R equal to root p square plus q square plus 2pq cos theta formula. And from this formula we get, just substituting the below, we get the result to cos 30 degree. By calculating, we get the below of R, resultant vector. And to find the angle in which direction R act, let us consider the direction makes an angle alpha with P. Then we get the formula from alpha equal to tan inverse Q sin theta divided by P plus Q cos theta. And from this formula we get tan inverse Q. Q means 20 Newton. 20 into sin theta, 30 degree, sin 30 degree divided by P 10 plus Q 20 into cos 30 degree. So by calculating tan inverse 20 into half divided by 10 plus 20 into root 3 divided by 2. By this way we get tan inverse below, and also we get the alpha. So by this way we get the resultant vector and angle makes with P. So what whether the angle makes with Q? To find the angle makes with Q, it means theta minus alpha. So you know theta equal to 30 degree and also get alpha from this equation. So we also can be calculated the angle makes with Q. Now we will discuss a very simple method to find the resultant vector of a number of vectors. Suppose there are a number of vectors in xy coordinate system, x and y. Suppose f1 vector act along this direction and makes an angle theta 1 with the x-axis. f2 vector act along this direction, makes angle theta 2 with the x-axis. and f3 vector along this direction makes an angle theta 3, and f4 vectors makes an angle with the x-axis theta 4. So the simple method is to find the component of all vectors along x-axis and component along y-axis. So the resultant vector is the sum of component of all vectors along x-axis and y-axis. We can write resultant vector f equal to f1 vector plus f2 vector, f3 vector, f4 vectors. Also we can write fx I cap plus fy j cap. So f1x I cap plus f1 y j cap plus f2 vector, this is also x component y component, this is f1 vector x component y component, and x component y component of f2 vector f2x I cap plus f2y j cap. Similarly f3 in this way dot dot. So we can write fx only I component of I, fx resultant vector component, this is the component x component of resultant vector, the sum of x component of all other vectors, f1x plus f2x plus f3x plus f4x. Similarly fy f1y plus f2y plus f3y plus f4y. So first of all we need to calculate the x and y component of all vectors, and then sum of x component give the x component of resultant, and sum of y component give the y component resultant. Now how can we calculate this? We already know that a vector f makes an angle theta with the x-axis. Component of f along x-axis f cos theta and along y-axis f sin theta. So component of fy along x-axis f1 cos theta 1, component of f2 along x-axis f2 cos theta 2, because theta 1 is the angle mixed with the x-axis, theta 2 is the angle mixed with x-axis, all this angle will be with the x-axis. Then in this case component will be always cos theta and y component always sin theta. If theta makes with x-axis, then component always f cos theta and y component will be always f sin theta. So we can write component of f1 along x-axis means f1 cos theta 1, and component of f2 along x-axis, component of f2 makes angle theta 2, f2 cos theta 2, plus component of f3 makes theta 3, f3 cos theta 3, plus component of f makes theta 4, f4 cos theta 4. This is all x component of individual vector, therefore this is equal to fx. So we can write fx equal to f1 cos theta 1 plus f2 cos theta 2 plus f3 cos theta 3 plus f4 cos theta 4. In the similar way fy y component all will be sin, f1 sin theta 1, f2 sin theta 2, f3 sin theta 3 plus f4 sin theta 4. These are general equations to find the resultant component of numbers of vectors. And if we calculate fx and fy, then the resultant vector f vector will be fx I cap plus fy j cap. And angle with respect to x-axis we can write, suppose this is f vector and the theta makes an angle theta with the x-axis. So this is fx, component of f along x-axis and component of y along y-axis. So this is y, means this also y, these two are equal. Then we can find the angle theta by tan theta equal to perpendicular divided by base fy divided by fx. By this equation you can find the direction of resultant vector with respect to x-axis. Now consider this problem. This is also very simple problem. Let A1, A2, A3, A4 be this is a rectangular hexagon. Write the x component of the vectors represented by 6 sides. 6 sides means 6 number of sides. Suppose this vector can be represented by F1, F2, F3, F4, F5 and X6. The 6 sides taken in order. Use the fact that the resultant vector sides taken in order. Use the fact the resultant of this 6 vector is 0. Resultant of this 6 vector is this. That means resultant vector f vector equal to f1 vector plus f2 vector plus f3 vector, f4 vector plus f5 vector plus f6 vector. This is 0, means equal to f vector also can be represented by fx I cap plus fy j cap equal to 0. This is the resultant vector equal to 0. That means fx equal to 0 and fy equal to 0. If the resultant vector equal to 0, then their component also equal to 0. So this is the fact. So the fact that the resultant vector equal to 0, this fact resultant vector equal to 0, then fx equal to 0 and fy equal to 0. To prove that, this is when to prove. So how can we calculate this? By fx and fy, we know the component of f vector along the x-axis, and for this purpose we need to first of all find the angle of f vector. First f1 vector. So f1 along this x-axis means angle between the f1 and x-axis equal to 0. So we can write theta 1 equal to 0 degree, and f2 vector along this direction. So and in case of hexagon, we know that the angle between the every side, between the consecutive side, 120 degree. So this angle will be 180 minus 120, 60 degree. So similar way, this is also 60 degree. This is also 60 degree. So with the x-axis, f2 makes an angle with 60 degree, then we can write theta 2 equal to 60 degree. And similarly, this is the direction of x-axis. So what will be the angle of f3? This is 60, then this is also 60. 60 plus 60, 120 degree, then f3 equal to 120 degree. Similarly, we can write along this direction, x-axis along this direction. So f4 makes an angle with the x-axis 120 degree. f4, this is the opposite of x-axis. Then f4 makes an angle with the x-axis theta 4 equal to 120 degree, and this is also 60 degree. So f5 makes an angle 180 plus 60, then theta 5 equal to 180 degree plus 60 degree means 240 degree. Similarly, in the same way, in every step 60 degree will be added. For 60, 120, 180, in this way 240 plus 60, then theta 6 will be 240 plus 60, then 300 degree. So by this way we get theta 6 equal to 300 degree, or we also can be written as pi equal to 180 degree, then 120 degree will be equal to pi by 180 into 120. In this way we can also calculate 0, 6 into 2, 6 into 3. We get 2 pi divided by 3. Therefore, 120 degree can be written as 2 pi divided by 3. Also, in the same way, 60 degree equal to pi divided by 3. This is the very simple method, 60 degree. For every angle, theta 1 to theta 2, 60 degree, this is step by step at 60 degree. So 60 degree, 120 degree, 180 degree means theta 1 equal to 0. First of all, theta 1 equal to 0. Theta 2 equal to 60 degree, pi by 3. Theta 3 equal to pi by 3 plus pi by 3, 2 pi by 3. Theta 4, another 60 degree will be at 2 pi by 3 plus pi by 3. Then equal to 3 pi divided by 3 equal to pi. Theta 4 and theta 5 equal to pi plus pi by 3 equal to 4 pi by 3, and theta 6 equal to 4 pi by 3 plus pi by 3 equal to 5 pi divided by 3. So we get all the angles. Now we can calculate the x component of a resultant vector as fx equal to f1 cos theta 1 formula, f2 cos theta 2, f3 cos theta 3, f4 cos theta 4 plus f5 cos theta 5 plus f6 cos theta 6. There are 6 sides represented by f1, f2, f3, f4, f5 axes. In this way, we can write every side is equal. Therefore, f1, f2, f3, f4, all sides length of this side. f1 represent the length. So f2, every side is equal of a second. Then we can write f1, f2, f3 all are equal. So you can common the f1 cos theta 1 cos 0 plus cos theta 2 pi by 3 plus cos theta 3 2 pi by 3 plus cos theta 4 pi plus cos theta 5 4 pi by 3 plus cos theta 6 theta 5 and theta 6 5 pi by 3. So we also already written as fx equal to 0. Therefore this is 0. This means we can write cos 0 degree plus cos pi by 3 plus cos 2 pi by 3 plus cos pi plus cos 4 pi by 3 plus cos 5 pi by 3 equal to 0. This is proof as cos 0, cos pi by 3, cos 2 pi by 3, cos 3 pi by 3. 3 pi by 3 means 3 or pi. Cos 4 pi by 3, cos 5 pi by 3. This is hence proved. So by this way, use the known cosine below to verify the result. Just substituting the below of this, we can get 0. So cos 0 equal to 1. Cos 60 degree. Cos pi by 3 means cos 60 degree. Cos 60 degree plus cos 120 degree plus cos 180 degree plus cos 180 plus 240 degree plus cos 300 degree. So the left hand side, from left hand side we get 1 plus cos 60 degree means half, and cos 120 degree can be written as cos 90 plus 30. So this is very easy, everyone can do. Then cos 180 degree minus 1 plus cos 240. Cos 240 can be written as cos 180 plus 60, and cos 300, cos 360 minus 60 degree. In this way, 1 plus half cos 90 plus 30. 90 plus 30 means sin minus sin 30 degree. Minus sin 30. This is already we know in trigonometry formula. And minus 1 plus cos 180 plus 60. Cos 180 means in the 180 plus 60 there is all positive. Here sin and cosec positive. Here tan and cot positive. here cos and sec positive. So cos 180 plus 60 means in tan and cot region, therefore it will be negative. The minus cos 60 degree plus cos 360 minus cos 360 means cos 360 minus 60 in cos, so it will be positive. The cos 60 degree. So you get 1 plus half, and cos sin 30 degree minus half minus 1, and minus cos 60 degree and plus cos 60 degree already cancelled, and therefore 0. Then plus 1 minus 1 0, plus half minus half 0. So the right hand side. Hence proof. Let us consider an example from S.C. Burma, which is one of the best book for physics for joint entrance exam. The problem is from the figure, the magnitude and x and y component and the angle with the x-axis of the resultant, the angle with the x-axis of the resultant of this three vector. So we can write these three vector as f1 vector and f2 vector, f3 vector. These three vectors. Find the angle with the x-axis. The angle with x-axis along this direction, there is vector acting 30 degree. So 30 degree is the angle makes by f1 vector with the x-axis. But vector C along this direction, so the angle will be 180 minus 60 degree equal to 120 degree. This is the angle makes with x-axis by C. So you can write this as theta 1 and this as theta 2, and this vector with the angle x-axis along this direction, so the positive x-axis, the angle makes with positive x-axis 360 minus 90 degree. 360 minus 90 equal to 270 degree. So f1 vector makes angle theta 1 30 degree with the x-axis. f2 vector makes angle 120 degree 20 degree with the x-axis, and f3 vector makes an angle theta 3 273 degree. The angle with the x-axis of the resultant So resultant we can find by f vector equal to fx I cap plus fy j cap, and then we angle theta equal to tan inverse fy divided by fx. This is the formula. So first of all we need to calculate the fx and fy, where we have the formula fx equal to f1 cos theta 1 plus f2 cos theta 2 plus f3 cos theta 3. Just substituting this 2 cos 30 degree plus f2 1.5 cos 120 degree plus f3 1 to cos 270 degree. So 2 into root 3 by 2 plus 1.5 cos 120 degree cos 90 degree plus 30 degree plus cos 270. Cos 270 means 0. Cos 90 degree 270 degree is 0. So from this equation you get 1.5 cos 90 degree plus 30. Cos 90 plus 30 means 90 plus 30. By this trigonometry formula we know this is sin minus sin 30 degree. Here all are positive. Here sin and cosine. Here tan and cot positive. Here cos and sec positive. So 90 degree plus 30 degree means in sin, so cos will be negative, and cos 90 plus 30 equal to sin 30 degree. So we can get into minus half. So we get fx by calculating this. In the similar way we also get fy. F1 sin 30 degree plus f2 sin theta 1 plus f2 sin theta 2 plus f3 sin theta 3. Just substituting below, we get 2 into sin 30 degree plus 1.5 sin 120 degree plus 1 into sin 270 degree. So by calculating, we get fy. Then we get the angle theta. Tan inverse fy by fx. By substituting, we get the value fy. Then by substituting, we get the answer theta. This is very simple method. And the x component, y component, this is the x and y component. And the magnitude f equal to root fx square plus fy square. Just substituting the value of fx and fy, you get the result. This is very simple. I just do not want to waste your time. It can be very easy and everyone can calculate it in your home practice. So you can regularly practicing by this formula. And so by calculating the component of fy and fx and fy, we get the resultant vector f by root fx square plus fy square. And also the direction theta mixed with the x-axis can be calculated by this formula. So you need to more and more practice in your home. Also, if you have any problem or any doubt, so message me in the message box. I will definitely reply everything. Okay, bye.